Hi, AP Physics 1 and 2, it's Mr. Neff. Let's review this two-coil worksheet. Before we do you know sign language? Well, you gotta watch to the end of the video to hear the answer. Well, look what we have here. We have a coil on the left that has its own battery, and so its own way of making current flow. As soon as we close that switch, you can see what's going to happen. The current is going to flow to the left across the resistor. We're going to close that switch, and current is going to flow to the left across the resistor like this. Now, that's going to flow up this way, and you can see how that's wrapped. That's important. Every time it goes across the front, it's going towards the top of the coil. See, towards the top of the coil, towards the top of the coil. Just put a few of these in here. And then if you would take the fingers of your right hand and make them go around the way that that current is going. So if you could see my right hand right now, my fingers would be going towards the page above the coil and coming out of the page below the coil. My right thumb is pointing over to the left. And so that's saying that the magnetic field is pointing over here, something like that. But more importantly to this problem, that magnetic field is going to be pointing this way. And so I've introduced some field lines in this area between the two coils. And to me, most important, I've introduced field lines inside of this loop right here where there used to be none. Now, you can see something that's noticeably missing over on coil 2 is a battery. That doesn't mean that no current's going to flow. We're going to get an induced current flowing over here. So let's take a look at number 1. Immediately after the switch is closed, in which direction does the magnetic field point inside coil 1? That's pointing to the left. And in what direction does the induced magnetic field point in coil 2? Well, the induced magnetic field is just a continuation of those lines that I already drew. It's also pointing to the left. Number 2 says immediately after the switch is closed, in which direction will the induced current flow through resistor R in the coil? Well, as we know, these newfound field lines are not welcome by nature. Nature is going to try to cancel those out, and a vector to the left is going to be canceled out by a vector to the right. And so this is the induced field. Now, remember, that induced field is an effect. Its cause is a current that's flowing around there. How can I figure out which way the current's flowing? I'm going to use the right-hand rule. So right now, my thumb is pointing to the right in the direction of that induced field. And you can see your right fingers are going to be going from top to bottom this way. That is, your fingers would be coming out at you across the top of this coil and going away from you in the bottom of the coil. All that is to say, the current that's causing this field that nature's putting in to try to cancel out those field lines that came about whenever the switch was closed, that current is flowing down this way. And so every time you see one of these wires on the right picture, the current's flowing down. And to me, the most important one is this one over here. You can see the current's flowing down on the far right, and it's flowing across the resistor. It's capital R. I covered it up with those X's, but it's flowing across there from right to left. And so I'm going to say that is from right to left. Let's take a look at number 3. After the switch has been closed for a long time, in which direction will the flow in resistor little r, it's the one on coil 1, it will flow, and what about big R? Well, after it's been closed for a long time, the current's just going to continue to flow over on this left side. And so we're still moving from right to left in little r. But for big R, since it's been closed for a long time, this field will be here, but it'll be a constant thing now. And so nature is going to quickly get used to it. And after it's been closed for a long time, this field is going to go away. And remember, that's the effect. And so this cause goes away too. And so nature is going to have no current flowing over here because she has quickly gotten used to this flow. And so in resistor big R, we have no current flowing anymore because it's been closed for a long time. Remember, a magnetic field isn't a battery. A changing magnetic field has the effect of a battery. Let's look at number 4. Assume the switch S has been closed for a long time. If coil 1 is moved towards coil 2, in which direction will the induced magnetic field point in coil 2? So now think of it. Right now, the way I have this drawn, only one of these field lines is going through this area. But if I would move that closer, now this field line that is missing, if it were closer, would hit it, and this one perhaps too. And so I'm going to have more field to the left inside of coil 2, and nature's not going to go for that. Everything I said a second ago about the field that's introduced by nature to cancel out this new field, it comes right back. And so I'm going to have a induced field. And where do I get that from? Well, I get that from a current that's going to be going down this way. Again, I would take the thumb of my right hand, point it over to the right, because that I know that field is going to be there. From Lenz's law tells me that. And so now my fingers, as they go around this coil, they're going to go up the back. I'm not drawing that. And they're coming out and over the top. Here are my fingers coming out of the page. My fingers are going down in the front. And here are my fingers going into the page down here. This represents the current. So you can see that I'm going to get that flow across resistor big R from right to left. Let's look at number 5. If switch S has been closed for a long time and coil 1 has suddenly moved away from coil 2, in which direction will the induced magnetic field point inside coil 2? In which direction will the induced current flow? So we're going from this coil 1 being close to a situation where coil 1 is going to be far away. Well, what that's going to do is that's going to take us from a spot where maybe a lot of these field lines are hitting this area to a spot where they're not anymore. And so we're removing them. And so nature is not going to go for that. Nature's going to say, hey, I actually want those field lines there. Ironically, nature was just fighting against those field lines, but now nature's going to want to replace them. And so here's the induced field. Don't confuse the induced field with the field that's already there, but just notice that field I drew in purple, the field that's caused by coil 1, is getting weaker because we're moving coil 1 farther away. And so nature will superimpose some more field on there to cancel out as much of the change as possible. Now, what kind of current causes that field over to the left? Well, obviously it's going to be the opposite way, but let's go through the motion. Let's say that our thumb is pointing towards the left, and now our fingers are going to be going not down the coil, but up the coil. And so this would be the path of your fingers going across here. To me, most importantly, this last one, it's going to be going up, and to feed that, we're going to say that that induced current is going to flow across there from left to right. So the current is left to right. And as you can see what I said before, the field is pointing to the left. And last, number 6, suppose again that switch S has been closed for a long time, and then the switch is suddenly opened. In which direction will the induced magnetic field point in coil 2? I don't know if you can see how this is redundant, but it is. The same thing is happening. So rather than us moving the coil 1 away and making less of these field lines hit, we're just opening it up. And so the switch is open. That's going to cut off this current. That's going to cut off this field. That's going to cut off this field over here. All this purple stuff that I drew, not the area, but all the purple stuff that I drew is going to be there. And nature's not going to go for that. And so nature is going to superimpose a field where the one was just lost. And so the picture that I still have remaining here in red is still a good picture. that we have our field that is our induced field replacing the one that was just lost, pointing to the left, and remember that's the effect. The cause is the current flowing up this way, predicted by the right-hand rule. And so we have our current flowing across the resistor R from left to right, and the field pointing to the left. Hope that helps with the worksheet. And just before we go, do you know sign language? Well, you should, because it'll come in handy.